Hi guys, this is Vineet and I welcome you to this video. Today's video topic is date and time data types in SQL Server, and this is part 4 of this video series. If you haven't watched the earlier 3 parts of this video series, please go ahead and do so. I would highly recommend that. So let's start with this topic, which is a part 4 of this data type series. So let me take you to notes quickly. So today we have to continue with one of the demos of this video. So the demo is basically we will show you how you can convert the datetime offset data type to other date and time types. And in this demo, basically we will describe what occurs when the datetime offset data type is converted to any other date and time data types. And basically when we convert to date, the year, month and day are copied as is. And let me show you with an example of a code. So let me take you to SQL Server quickly. I've just launched the SQL Server. I will write in some code. You can write that along with me. So guys, Microsoft SQL Server is about to get launched. I think it's already launched in the background. So let me take you there. So let's log in into the default instance of SQL Server we have on our machine. You may execute a new query against any of the databases. So select any of the databases. If you have AdventureWorks 2022, it's best. Otherwise, you can also open the query against the master database or any other system databases. Just click on new query to open up a new query window, and we will write in some code here. So you may also write this code along with me. So I'm starting with the declare statement. Basically, I'm declaring a variable which can be declared with the declare statement, and variable can be defined with the @ symbol. And let's take datetime as one of the variables. This is the variable name, and I'm taking this variable of type datetime offset, and I'm taking 4 in the bracket. Let's initialize this variable to a particular datetime value. So datetime offset basically also support the zone information as well. So let me put in a date with the zone info. Let me put 12/7/2025, and along with that, let's put 12/32, and let's put seconds as 10, and let's put time zone as plus. This is the offset I'm putting, so it's GMT +1. So this is the time value I'm initializing this variable to. In my second statement, I'm declaring another variable, which is of date. The variable name here is the date. Don't confuse it with the type. So I'm declaring a variable name with the date. It's proceed with an @ symbol. And after that, let's specify this variable of type date. Let's put equal and initialize it with this particular date variable. Let me initialize with the datetime offset variable. So copy this variable name and put it here. So whatever value gets stored in the datetime offset will also get, I'm trying to store that value in the date variable. If we talk about this value will get stored in the datetime offset. It will store the date completely along with the time and the offset information. However, if the same variable gets sent to the date variable, which is of date type, only the date part of this information will get stored to the date variable because it is of just of date type. So second information and the offset information will not get stored in this variable. All right, so let me write a select statement after this. So you may write select statement. Let's output the value of the first variable, which is the date time offset, so that we can see what is stored inside this variable. And let's take the column name as the datetime offset. Let's take the column name as this, and let's output the second variable as well. Put out the date variable, and let's take the column name for this as a date. All right, so these three are our statement which we need to execute. If you haven't write it, please write them down right away. And I'm executing these three statements now together. So let's execute this statement. So first I have printed the datetime offset. It has stored the complete date along with the offset information, as you can see here, right? And after that, I'm outputting the date variable, which has stored the part of this datetime offset, which stores the complete datetime information with the offset information. So this date variable only stores the date part. So that's why if I print date, only the date portion is coming over here. So I hope you got the idea of this. We can also try to convert it into the time format as well. So let me change this query a little bit. So if the conversion is to time and the hour, minute, and second and fractional headings are copied, the time zone value is truncated. And when the precision of the datetime offset value is greater than the precision of the time and value, the value is rounded up. Let me show you with an example of a code. So here I have taken the datetime offset value with the 4 precision. Let me take another variable over here. Let's call it a time variable here. Mark it as time and take it as time type. Right, and I'm putting the result of this information into this particular variable. And let's try to print this variable. Now we don't have date variable, so let's put time variable over here and let's take it as time. And this time I'm taking this time variable along with the precision of 3. All right, so let's see what comes up. So in our previous execution, we saw that after seconds, we saw 4 zeros. We haven't stored the precision information over here, which is basically milliseconds. We have not stored that information, but otherwise the datetime offset do store the precision information as well. So let me put some milliseconds information as well. Let's put it as 1237 milliseconds. Now the datetime offset variable will store this complete information along with these 4 precision dates as mentioned over here. If it's 3, it will only store the 3 numbers from here, right? That's why I've taken time as 3, so it will only store the 1 to 3 as under the time value, and the time part as well. This will get stored in the time variable. Let me show you that by executing this query. So I've executed this query. If I talk about the complete datetime offset variable, it has stored the complete information like date, the time, and the precision is 4 digits, and it also stored the offset information. Whereas I'm outputting a time variable, and I've defined time as the with the precision of 3 digits, and it has stored the time information along with 3 digits. And if you see, it has rounded up the last digit, which is 3. It has rounded it up to 4. So that is what happens when you try to convert to a less precision value, time to a less precision value. Now let me take you through another example. Now what I will try to do is I will try to convert the datetime offset into the datetime type. When we try to convert to datetime, the date and time values are copied. So guys, we were talking about when you convert to datetime offset type to a datetime type, the date and time values are copied. The time zone information gets truncated, basically the offset information. And when the fractional precision of the datetime offset and value is greater than the 3 bits, the value is truncated because the datetime type stores the time value with the 3 precision. And let me show you with the help of an example. So we have taken the same example. Let's take datetime offset and storing that value into that datetime offset variable. Let's take the datetime variable over here. Let's name it datetime and take it as datetime type without any precision. By default, the precision is 3 digits. So let me take that and store the datetime offset information into the datetime variable. Now let's try to print the datetime variable over here. All right, and let's take it as datetime. Now let's try to execute this query and see what gets stored as a fractional part or millisecond part. Ideally, it should be rounded to 1 to 4. And this information will get truncated, and this is the offset information. Let's try to execute this statement and let's see the result. So this is the information which got stored in the datetime offset variable, which I'm printing here. So date along with the time along with the 48 milliseconds fractional part, and the offset information is stored in the datetime offset variable, whereas the datetime has stored the date as well as time, which is 12:30 to 10 seconds. And by default, it stores the millisecond with the precision of 3 digits. So it has taken 1 to 3 as the first 3 digits. So here rounding off did not happen, but it simply stored the first 3 dates of the milliseconds value. Now let me try to show you conversion into a small date time. So whenever we try to convert the datetime offset into the small datetime data type, let's take it as small datetime. For conversions to small datetime, the date and hours are basically copied, and the minutes are rounded up with respect to the second value, and the seconds are set to 0. And let me show you with an example of code. So first 2 lines are clear. I've defined the datetime offset data type, storing this value into that, and I declared a small datetime data type. Let's declare it as small datetime type. All right, and let's try to print it here. The same variable small datetime where we have stored the value of the datetime offset, and let's take it as small datetime. Let's try to execute this statement. Now we see if we try to print the datetime offset variable, we got the whole information, the complete date, the time, the seconds, and the milliseconds part, 4 dates, and the offset information all is displayed over here. Whereas if we store the same information in the small datetime variable of type small datetime, we get the date part as is. And if we take a look at the minute, we got the hourly part as is, we got the minute part as is, but the seconds are rounded up to 0. So if we use the small datetime value or data type, your seconds will get rounded up to 0. Only the hour and minute information will get preserved. The second information will get rounded off to 0 or is set to 0. Alright, so let's try to use another variable type or data type for conversion. This time let's take it as datetime2 with a precision of 3. So this is another type, the datetime2 type, and let's take it as datetime2 with a precision of 3 digits. All right, and let's try to print that. So let's try to print the datetime2. This is the variable, and let's take it as datetime2. So whenever we try to convert this datetime offset information into the datetime2 type with a less precision than the datetime offset, the date and time information gets copied right to datetime2 value, and the time zone information gets truncated. So if we use this data type, and the time zone or offset information gets truncated, and when the precision of the datetime2 is less, basically here we don't have a greater precision than the previous one. So when the precision of a datetime n value is greater than the precision of the datetime offset value, the fractional seconds are truncated to fit. And let me show you with an example. So here we have more precision in the datetime offset, whereas we have less precision in the datetime2 data type. And let's try to print this. Let's see. So this is the value gets stored in the datetime offset data type, which stores the date, the hour, minute, and second, and the milliseconds part for date precision mentioned over here. And apart from that, the zone information is given over here, or the offset information is given over here. And if the same information gets converted into the datetime2 offset data type or datetime2 data type with a precision of 3, we preserve the date part as is, and we preserve the hour part, minute part, the second part, and as we are taking only 3 digits for the precision of milliseconds, the information gets rounded off to 3 digits. So 1237 got rounded off to 124 over here. So this is what happens when we can try to convert the datetime offset type to the datetime2 data type. Now let me take you back to notes. So let's talk a little bit about the conversion of string literals to datetime offset. So in our example, we have taken a string literal. So this is a string literal, right? So let's talk about it. So here we are talking about the converting string literals to datetime offset. So conversion from string literals to date and time types are permitted if all parts of the string are in the valid format. So this is one of the valid formats where we have taken date, time, milliseconds, and the offset information in the valid date time format. All right. So this is basically a string literal, but in valid date time format. So the conversion happens easily because the format is correct. So this is what it is saying: conversions from string literals to date and time types are permitted if all parts of the string are in the valid format. Otherwise, a runtime error is raised. Now let's talk about another data type, which is the small datetime data type. Okay guys, let's talk about the small datetime data type. And if we talk about this data type defines a date that is combined with the time of the day. And this particular time is based on a 24-hour day format with seconds always set to 0 and without any fractional setting. So this data type basically do not contain any fractional seconds. It just contains the hours and minutes along with the 0 seconds. It also does not store any specific seconds information. It will always store the second information as 0. And basically we would recommend using the time, date and date and 2. And these three are the data types that we would recommend you to use. And basically the time and date time offset data types for any new type of work. So these 5 data types basically: time, date, date time 2, date time offset. For any new kind of work, please try to use these data types. And basically these data types are more portable and also provide more seconds of precision. And date time offset provides the time zone support as well for any globally deployed applications. Let me briefly discuss about this small datetime data type. If we talk about the usage, we can declare a certain variable. Here we have taken a my small datetime variable of small datetime type, and here we have shown you the usage in a table statement, create table statement, where we are creating a table name and we are defining a column name, column 1 with the small datetime data type. And the date range for this data type, it can store to date from 1900 0101 till 2017 90606. It can store dates between this range, or if we talk precisely, we can store anything between January 1 1900 till June 6 2079 in this data type. And if we talk about the time range, we can store anything in the 24-hour time clock. And we store this information, this date and time information, into the small datetime data type. This will get rounded to date, and the date will also get rounded to, because if we add 1 second to this date, it will round off to next date. So this will round to 10/5/2007. Here we have 9/5/2007 with the exact last second in the next day. This will get rounded off to next day if we store that information in the small datetime variable data type. Here the YYYY represents the 4 date ranging from 1900 to 2079. That represents the year. MM is 2 dates ranging from 1 to 12, and this represents the month of a specific year. DD represents the date. The values are from 0, 1 to 31. And hour represents 2 dates. HH represents hours. This ranges from 00 to 23. And MM represents the minutes, which ranges from 00 to 59. And SS represents seconds, which is 2 date, and it ranges from 00 to 59. And that represents the second values that are 29.998 seconds or less, are rounded down to the nearest minute. The character length of this data type is 19 positions maximum, and the storage used for this data type is 4 bytes, which is a fixed storage. It's not variable, and it has an accuracy of 1 minute. And default value, if we don't put any value, it will take this as the default value. And calendar type used is Gregorian, and user-defined fractional second precision facility is not provided here. This data type is not time zone offset aware, and daylight, this also does not daylight aware, or does not store any information related to date and time type. Now let me take you through some demos over here. So first we will talk about converting the small date time data type to any other date and time types. So first of all, we will talk about converted date and time data. And when you try to convert the date and time data types, SQL Server rejects all values it can't recognize as dates or times, and that is the basic thing. And let's talk about this particular demo now, where we'll try to convert the small date time to other date and time types. And basically in this demo, we will describe what occurs when a small datetime data type is converted to any other date and time data types. And basically for a conversion to date, the year, the month and day are copied. And let me take some code over here. Let me try to modify the existing code. and you can modify the code along with me. So let's modify this part. Let's take it as small datetime as our first variable name. Let's take it as small datetime type. Let's store the value. Let me store a specific value because it does not store the offset information. So let me put a specific date. So let's take 1955, 12th month, 13th date, and let's take 12 hours, 43 minutes, and 10 seconds. Let's try to store the value, this which is stored in the small datetime data type. Let's try to convert it into the time type or date type. Let's take the date type data and let's take it as date type. This date is a variable and this is a data type, and let's take it as assign the value of the small datetime data type to the date variable. Let's try to print this over here first, the small datetime data type. Let's take it here as well, and let's try to print the date variable over here. So let's print this date variable, and let's take the column name as date over here. All right. So this is the information which will get stored in the small datetime. We are trying to assign this information indirectly to the date variable. So let's see what gets stored into the date, because date just stores is of date data type and it will just store the date part, which is 13 12 1955. This is the only information which will get stored in the date data type. Let's try to execute this statement. So here we see we have tried to print the small datetime variable which has stored the date part, and for the time part it has just stored the hour, minute. It has not stored the second part, which is 10. It has not stored that. The date variable has only stored the date part, which is this part. So this was one of our example. Now let's try to convert the same information into the time and format, and let's try to take an example here. Let's take the time variable and let's take the time data type. Let's keep it as time data type with a precision of 4 seconds or 4 milliseconds. I'm assigning the small datetime value to a time data type. Let's try to print this info. All right. Now this is the information, only this much will get stored in the small datetime data type, and the seconds will get rounded off to 0. And whereas for time, we are using the time for variable, the 4 dates precision for the milliseconds. So time will only store the time information, the hour, minute, and second part. Along with that, it will show the 4 millisecond dates as well. It will take all of them as 0, I think. So let's see what information do we get. So we have executed. The small datetime will get printed as this. The second part is discarded, truncated, and 0 seconds are showing up over here. Whereas if we take a look at the time part, we only see the hours, minutes, and seconds are even not stored accurately, and also the millisecond information is rounded off to 0. So the time value also truncates any second related information. It does not preserve the second information if we assign any second information to the time value. Now let's try to play with converting the small datetime into the datetime data type. Let's take datetime data type as datetime. Okay, we have taken a variable datetime of datetime data type, assigning the value of small datetime to this datetime variable. Let's try to print this datetime variable here with the datetime as column header. If we assign this information to the small datetime variable and try to print it, it will truncate this second part and it will set it to 0 0. Whereas if we assign this information will get assigned to the datetime part. So it will store all the information as is. So the value of small datetime and the datetime will be same here. So when the conversion is to datetime, the small datetime value is copied to the datetime value. The fractional seconds are set to 0. Here we are not using any fractional seconds, but otherwise if we are using any fractional settings, they are set to 0. So here if we execute this code, I think both the values will be same under both the columns. So this value and this value, this is same, but in addition it is also showing us the default 3 fractional seconds or the milliseconds. Let me take you through another example where we will try to convert the small date time into the date time offset type. So let's take date time offset over here and take the same data type over here. Date time offset with the precision of 4 I'm taking here for fractional milliseconds, and I'm assigning the value of small date time to this date time offset data type. And let's try to print this. Let's take it as column header as well. Now, if we execute this statement, the same value 1955, 1213, and 124300 will get printed for the small data time. And if the same value this value gets assigned to this datetime offset, it will be printed as is, and the time zone offset will be set to plus 0000, and the fractional second should also be set to 0000. So let's try to execute this. Yeah, here we have seen. So the date and time information is same. Along with that, we see 4 dates of these fractional seconds, which are set to 00, and zone information is also set to plus 0000, which is the UTC zone. All right. So for a conversion into datetime offset and type, the small datetime value is copied to the datetime offset and value. The fractional seconds are set to 0, and the time offset zone is also set to plus 0000. And we have shown you this with an example of this code, which I think you must have executed. Now let me take you through a last example for this demo, and let's try to convert this same information into datetime type 2. And let's take the datetime 2 with an offset of 4 here, and let's try to print this information. Let's print datetime 2 and also specify the header as datetime 2. Now the same information will get stored in the small datetime, and this will store and display this information, right? And if the same information gets converted into the datetime 2 data type, which is a 4 which we have taken with a precision of a 4 milliseconds, so it will show 0 as milliseconds, and I don't know whether it stores the zone information. I think datetime 2 does not stores the offset information or the zone information, so it will just show the milliseconds with 0000 because 4 is mentioned over here. So 4 date precision will be there. So when we execute this code, we see the small datetime format, and the same data is copied over to the datetime 2 data type, and it is just showing the additional 4 fractional milliseconds over here. So done with this example, let's move on to next example where we are talking about the conversion of or casting of basically string literals with seconds to small datetime. So we will try to use different type of string literals, and we will try to store that information in the small datetime data type. So let's take some examples. Let me rub off this code. So I'm just using select statement and try to take 3 castings. So I'm using the cast function over here. I'm taking a datetime string literal over here. So let's take 2007, 5th is the month, which is May. 8 is the date, and let's take time information 12, 35, 29. This is the first string literal, and I'm casting this as small datetime. So let's close the bracket. Let's try to use another casting over here. Let's use another cast function. Let's provide the another string literal where I'm taking the same date and little bit different time. I'm taking 12, 35, and 30, and I'm converting it as the small datetime. And let's take the last casting, a different string literal. Let's take the same date, 2007, and the 5th month, and the 8th as date, and let's take the time, 12:59, and I'm checking 59 seconds over here. Basically, any second information is not preserved and basically gets rounded off. So here, if we talk about this last example, this will round off to next day completely. Whereas the other two, for other two examples, the second part will set to 00, and yeah, we don't see any change in the time and the dates. Let's see what happens. What will be the output? Let's take it as small datetime. Let's try to print this to see what will show up. Let's try to execute this statement. So for first casting, we see that second part got truncated and it's rounded off to 00 without any change in the minutes part. And for second casting, the rounding occurs because if anything is about 29 in the seconds, it rounds off to next in a minute. Otherwise, and also the seconds get rounded off to 00, but minutes get increased by 1. And for this casting or this string literal into small datetime, we see that whole day will change because it's 12:59:59. I don't think so whole day will change here because I think it will round off to 13:00:00. Yeah, that is what has happened because it's 12 hours 59 seconds, 59 minutes 59 seconds. This will round off to 13 hours, 0 minutes and 0 seconds. So guys, we have just shown you some of the string literals, how these can be converted into the small datetime data type. Let me see if there's anything pending over here. So yeah, if we talk about this third samples, we have shown you how you can convert the data and time string literals into various types, time, date time, small date time, date time offset, and date time too. So I think this demo specifically is not essential. You know how to do the conversions. So guys, I think we should round off our video here. In our next video, which will be this is part 4 of this video series, right? In our next video, we will cover up the time data type in the part 5th of this video series, and we will define the time data type, and we will take you through some of the demos related to time data type. Keep a watch. If you have not already subscribed to this channel, please go ahead and do so. There's a subscribe button below this video. Please click on that subscribe button. It will give you a bell icon. Click on that bell icon and select all notification to get notifications regarding all my future and upcoming videos. And guys, if you would like to donate to us, you can do that so by going to my topmate.io page, which is given over here. You can open up this link in your browser. You can type the link as is. It will take you to my topmate.io page where you can contribute donations starting 100 rupees. And it's up to you how much you want to donate. Other way to donate, if you're using any UPI based apps like Google Pay or Phone Pay, you can scan my code, which is given on the right hand side, and make any contributions as you like. All right guys, so let's come back to topic. We are done with today's video. I hope you like this video. If you really like this video, please click on the like button. Also share this video with your friends. I thank you so much for your time on this video. You have a great day ahead. Thank you.